In 1500 BC, a balding Egyptian man, presumably tired of looking in a polished bronze mirror and seeing more scalp than he'd like, recited a magic spell to the sun god, and then swallowed a cocktail of onions, iron, red lead, honey, and alabaster. It did not work. A few centuries later, in 1100 BC, a different group of increasingly desperate Egyptian men tried rubbing fat from lions, hippopotamuses, crocodiles, ibex, tomcats, serpents, porcupines, and geese directly onto their scalps, presumably hoping some of that animal's vitality might transfer through the skin and stimulate something useful happening underneath it. That didn't work either. When that failed too, someone apparently suggested sautéing the leg of a female greyhound in oil with donkey hoof and applying that mixture instead. Still nothing. At which point, having exhausted essentially every animal on the continent without results, the Egyptians did what any reasonable person would eventually do. They gave up on curing it and just started wearing wigs instead. This is the part of human history that almost never makes it into the highlight reel, and honestly, that's a shame, because it's genuinely one of the funniest, longest-running failures in the entire story of civilization. Humans have been losing their hair, panicking about it, and trying absolutely anything to stop it for at least 4,000 years of documented history, and the science finally explaining why this happens and how far back it actually goes turns out to be a genuinely fascinating mix of hormones, genetics, evolutionary trade-offs, and one specific migration out of Africa that may have quietly determined which populations on Earth would eventually develop the bald spot in the first place. So let's actually dig into when ancient humans started going bald, because the honest answer involves a hormone with a name that sounds like a villain from a science fiction movie, a genetic marker that apparently hitched a ride out of Africa roughly 40,000 years ago, 122 bald men casually painted onto the walls of Egyptian tombs by artists who clearly couldn't have cared less about the condition one way or the other, and the genuinely strange reason evolution has apparently been completely fine with letting this keep happening to roughly half the male population for tens of thousands of years without lifting a finger to stop it. Let's start with the biological mechanism itself, because understanding exactly what causes male pattern baldness at the molecular level is the key to understanding how far back in human history it could possibly stretch and why it shows up the specific way it does. Male pattern baldness, formerly called androgenetic alopecia, is driven primarily by a hormone called dihydrotestosterone, a byproduct created when ordinary testosterone gets converted by an enzyme called type 2 5-alpha reductase, which sits conveniently inside the oil glands of your hair follicles, quietly doing its work without you ever noticing until the results become visually unmistakable. In follicles that happen to be genetically sensitive to DHT, and this genetic sensitivity is the critical variable that determines whether any given man actually loses his hair or keeps it indefinitely. This hormone gradually shortens what's called the anagen phase, the active growth period of each individual hair, causing the follicle to slowly miniaturize over repeated growth cycles until it's eventually producing nothing but fine, nearly invisible vellus hair, instead of the thick, pigmented terminal hair it used to reliably grow year after year. Do this across enough follicles, concentrated specifically at the temples and the crown of the head, while the sides and back remain stubbornly, almost mockingly unaffected, and you get the classic receding hairline and thinning crown that eventually, in more advanced cases, leaves nothing behind but a horseshoe-shaped rim of hair around the back and sides of the head, a pattern instantly recognizable across virtually every culture on Earth. The reason the sides and back of the head are spared while the top gradually thins has to do with the distribution of androgen receptors across different regions of the scalp. Follicles on the top and front of the head carry significantly more androgen receptors than follicles on the sides and back, making them vastly more sensitive to DHT's miniaturizing effects. This uneven distribution is itself genetically determined, which is why the specific pattern of hair loss is so remarkably consistent from one balding man to the next, regardless of where on Earth he happens to live or what culture he happens to belong to. The horseshoe pattern isn't random bad luck. It's a precise, predictable outcome of follicle-level genetics, playing out the same way on every susceptible scalp that has ever existed. This isn't some rare genetic fluke either, confined to a small, unlucky minority of men who drew the short straw. Research analyzing over 205,000 men found the condition to be strongly heritable, with researchers estimating somewhere around 62% of the variation in male pattern baldness traceable directly to genetics passed down from close relatives within the family tree. A massive 2018 genetic study published in Nature Communications identified more than 600 distinct genomic locations associated with the trait, including a notably strong cluster sitting on the X chromosome specifically, inherited maternally, which is exactly why the old folk wisdom about baldness coming from from your mother's side of the family actually has some real genetic backing behind it, rather than being pure superstition passed down at family gatherings by uncles trying to assign blame. This is, in other words, a deeply, thoroughly polygenic trait built from hundreds of contributing genetic variants working together in complex combination, rather than some single dramatic bald gene waiting to be flipped on or off like a light switch by one unlucky roll of the genetic dice. Here's where things get genuinely interesting from an evolutionary standpoint, because researchers studying this trait across global populations have found something that should immediately raise an eyebrow. Many of the genetic variants associated with male pattern baldness are old, predating modern humans entirely, and shared in some form across multiple human populations worldwide, regardless of where those populations eventually settled. But the actual frequency of those variants, meaning how common they are within a given population, varies dramatically depending on ancestry, showing up considerably more often in populations of European descent and considerably less often in East Asian populations, even when comparing men of exactly the same age and otherwise similar life circumstances. This uneven global distribution has led some researchers to propose a genuinely fascinating theory about when and where male pattern baldness, as the widespread common trait we recognize today, actually originated as a distinct phenomenon. According to Charles Ryan, author of The Virility Paradox, by examining the specific ethnic and genetic distribution of male pattern baldness sufferers alongside the well-documented migration patterns of ancient humans moving across the globe over tens of thousands of years, researchers can trace specific genetic markers for the condition to populations descended from groups that migrated into Europe or the Middle East. Since these particular markers show up reliably in European populations but are largely absent in many Asian and African populations who never made that same specific journey, the implication is that whatever specific genetic mutations drove this particular version of male pattern baldness most likely emerged sometime after early humans migrated out of Africa into Europe, an event researchers generally place it somewhere around 40,000 years ago, give or take a few thousand years of uncertainty. If this theory holds up under further scrutiny and additional genetic sampling, it means the specific common form of baldness afflicting so many modern men may have a genuinely traceable point of origin sitting somewhere in that ancient migration, a single evolutionary event that quietly determined which branches of the human family tree would eventually be more likely to lose their hair, long before anyone involved could have possibly known or cared about the cosmetic consequences tens of thousands of years down the road. Now here's the genuinely frustrating part for anyone hoping for a clean, satisfying answer to the question of exactly when the first human went bald. We have almost no way of actually confirming whether early Paleolithic humans, the literal cavemen everyone pictures when they hear the word ancient, were walking around with receding hairlines, because almost none of them lived long enough for the condition to ever show up in the first place. Male pattern baldness typically becomes noticeable somewhere between the ages of 25 and 50, with roughly 30% of men showing visible thinning by age 30, and roughly 50% displaying significant hair loss by the time they reach 50, with the trait progressing gradually over years, sometimes decades, before reaching its more advanced, unmistakable stages. The problem, as Charles Ryan bluntly points out, is that early humans rarely lived long enough to actually experience it at any visible level. These people were dying of infections and trauma in their 20s, Ryan explains, so they didn't live to the ripe old age of 45. If the average hunter-gatherer life expectancy hovered somewhere well below the typical onset window for visible, recognizable balding, an enormous number of genetically predisposed men may have simply died of something else entirely, an infection, an injury, a predator, a failed hunt, before their hairline ever had the chance to noticeably retreat even a centimeter. This means the actual visible prevalence of baldness throughout most of deep prehistory was probably suppressed not by genetics or hormones at all, but by the simple, grim mathematics of ancient mortality filtering men out of the population before the trait could express itself. The genetic machinery for baldness may well have already been sitting there, fully assembled and ready to go, for tens of thousands of years before anyone actually managed to live long enough to demonstrate it visibly. It's worth clarifying an important nuance here, because the phrase life expectancy is frequently misunderstood in exactly the way that makes this particular topic confusing. When researchers say average life expectancy in the Paleolithic was somewhere around 30 or 35, they don't mean everyone dropped dead at 35 like clockwork. They mean that extremely high infant and childhood mortality dragged the overall average down dramatically, while the adults who actually survived past childhood could and sometimes did live into their 50s, 60s, or occasionally even beyond. This means some ancient men absolutely did live long enough to experience visible visible hair loss, just far fewer of them than in modern populations where the vast majority of people comfortably survive well past 50. Baldness in the deep past was almost certainly real, just considerably rarer as a visible phenomenon than it is today, simply because fewer men were reaching the ages where it becomes unmistakable. There's also a genuinely strange detour worth taking through the animal kingdom here, because it turns out humans aren't entirely alone in this particular biological quirk, though the company we keep is a little surprising and considerably more confusing than most people would expect. Chimpanzees, our closest living relatives, can in some documented cases experience significant or even complete hairlessness, but the pattern doesn't match classic human male pattern baldness at all, lacking the specific recognizable temple and crown progression that defines the human condition, which strongly suggests chimp hair loss isn't coming from the same underlying genetic source as ours, despite the two species sharing roughly 98.7% of their DNA. Researchers describe this instead as a case of parallel evolution, the same basic outcome, hair loss, arising independently through entirely separate evolutionary pathways in two related but distinct species, similar to how both birds and bats evolved functional wings despite having no shared winged ancestor anywhere in their respective family trees. Macaques also experience hair loss in documented cases, but they're considerably more distant from humans genetically than chimps are, and their baldness appears to be linked at least partly to stress-related hair-pulling behavior, rather than the hormone-driven follicle miniaturization seen in human men, and crucially, it shows up in both male and female macaques at roughly similar rates, which tells researchers it's almost certainly operating through a fundamentally different underlying mechanism entirely than the specifically androgen-driven process found in human males. Meanwhile, gorillas and orangutans, our other close great ape relatives, generally don't experience scalp hair loss at all in any comparable recognizable pattern, which makes the whole comparative picture considerably messier and more interesting than a simple, tidy story of all primates eventually go bald the same way, through the same inherited pathway. Whatever specific evolutionary pressures produced the uniquely human version of this trait, they appear to have done so largely on their own, independent of whatever's happening in the rest of our extended primate family tree. So why would evolution allow a trait like this to persist at all across tens of thousands of years, if losing your hair doesn't exactly seem like it would help anyone survive or reproduce more successfully in any obvious way? This is where things get genuinely interesting from a genetic standpoint, because the same 2018 genetic study that mapped out more than 600 contributing genetic loci also found something genuinely worth sitting with carefully. Male pattern baldness shows measurable genetic correlations with several other traits, including earlier puberty onset, increased bone mineral density, and the certain specific aspects of pancreatic beta cell function. Researchers even calculated an estimated linear selection gradient associated with the trait, suggesting it may carry a very slight but statistically measurable effect on overall reproductive fitness across large populations. This points towards something researchers call pleiotropy, a single gene or cluster of genes influencing multiple, seemingly unrelated traits at once, rather than baldness existing as some isolated, pointless genetic mistake floating around the genome with no purpose at all and no connection to anything else. If the same genetic machinery responsible for gradually thinning hair on the scalp is also tied to hormonal pathways directly involved in earlier sexual maturity, stronger bone development, or metabolic function, it's entirely possible that whatever modest reproductive advantage came bundled together with those other, more clearly beneficial traits was simply strong enough to keep the baldness-associated genes circulating actively in the population generation after generation, even though the hair loss itself offered no direct survival or reproductive benefit of its own whatsoever. Evolution, viewed through this lens, doesn't appear to have been specifically selecting for baldness at all. It was very plausibly selecting for something else entirely, something genuinely useful hiding further back in the same genetic web, with thinning hair just along for the ride as an unintended hormonally linked side effect that nobody could separate out from the package without losing the good stuff too. There's also a simpler, more mundane, but equally valid reason this trait persists so reliably across countless generations without ever disappearing. It overwhelmingly shows up only after a man's prime reproductive years have already largely passed. Since natural selection has a much harder time weeding out any trait that only fully manifests after someone has already successfully had children and passed their genes along, baldness genes face genuinely very little evolutionary pressure to disappear from the population, regardless of whether individual men find the trait personally appealing or not. The genes simply slip right past evolution's filters by showing up too late in life to meaningfully affect whether someone reproduces or not, and by that point, the genetic damage, if you want to call it that, is already done and and passed along to the next generation. Now let's get back to the actual archaeological record, because this is where the story finally produces some genuinely solid, tangible evidence rather than pure theoretical speculation and genetic modeling, and it comes from a place you might not immediately expect: ancient Egyptian tomb walls. In 2019, Egyptology professor Samar Kamal documented evidence of 122 bald men painted across private Egyptian tombs dating from roughly 2613 to 525 BC, a span covering well over 2,000 years of continuous artistic record produced by entirely different generations of artists and patrons. Most of these depicted men were shown as visibly aged, often with remaining white hair around the sides of the head and nothing on top, exactly the pattern you'd expect from age-related androgenetic hair loss progressing naturally over a lifetime, rather than some unrelated medical condition, deliberate head shaving, or stylistic artistic flourish. Crucially, these bald men weren't tucked away in some obscure corner of Egyptian art either, hidden or marginalized. They were depicted prominently across a genuinely wide range of social roles and everyday activities: farming, fishing, sculpting, working as scribes, and performing various other recognized occupations, suggesting baldness in ancient Egypt was simply treated as an unremarkable, entirely normal part of getting older rather than something worth hiding, mocking, stigmatizing, or singling out for any special attention. Kamal's research went even further than simple counting, finding that the ancient Egyptians had specific dedicated terminology for describing different stages and patterns of male baldness, incorporated a designated baldness line directly into their mummification practices to mark where natural hair ended, and recognized multiple distinct balding hairstyles as legitimate aesthetic choices rather than embarrassments, including options like keeping remaining hair short all around versus letting it grow longer specifically at the back while the top stayed bare. This suggests an entire, fairly sophisticated cultural framework had developed around managing, acknowledging, and even styling the condition rather than simply concealing it behind wigs and pretending it didn't exist. This stands in genuinely interesting contrast to the same culture's parallel, well-documented obsession with finding a cure through the various bizarre animal fat remedies we already covered, which tells you something deeply real about human psychology that apparently hasn't changed in 4,000 years of continuous civilization. Societies are perfectly capable of treating something as completely normal and unremarkable in public life while simultaneously spending enormous private effort and considerable expense trying to reverse it behind closed doors, with no apparent sense of contradiction between those two attitudes. And the attempted cures genuinely never stopped coming, stretching forward across an unbroken, almost comically persistent chain spanning multiple ancient civilizations that had absolutely no contact with one another. In ancient Greece, the physician Hippocrates, born around 460 BC, reportedly rubbed a potion made from horseradish, cumin, opium, beetroot, various unnamed spices, pigeon droppings, and nettles directly onto his own scalp, presumably motivated by considerable personal investment in seeing it actually work on himself rather than just on a patient. It didn't. Hippocrates did, however, make one genuinely important clinical observation that would take roughly 2,000 years to be fully explained by science. He noticed that eunuchs, men who had been castrated before puberty, never went bald. This observation, casual as it may have seemed at the time, was essentially the earliest recorded recognition of the hormonal link between testosterone and hair loss, a connection that modern endocrinology wouldn't fully untangle until the mid-20th century. Hippocrates noticed the pattern correctly. He just couldn't explain why it existed, and his attempts at treating it with pigeon droppings suggest he may not have been entirely sure what to do with the observation either. In ancient Rome, Julius Caesar spent years searching for practical ways to disguise his own thinning hair, eventually adopting the famous laurel wreath as a partial, strategically positioned solution, alongside what historians describe as the very first documented comb-over in all of recorded history, growing his remaining hair long in the back and combing it carefully forward to mask the bald spot on top. Cleopatra reportedly recommended her own remedy to him involving ground-up mice, horse teeth, and bear grease, which predictably also failed to produce any visible results whatsoever. Centuries later, King Louis XIV of France, after losing his own hair to a severe illness rather than standard pattern baldness, popularized the entire era of enormous, elaborate wigs at the French court, some of which reportedly weighed up to 20 pounds and, in a few particularly extravagant cases, even featured built-in cages housing actual live birds, which seems like exactly the kind of solution you arrive at when every other option has been tried, and has already failed spectacularly. What's genuinely remarkable about this entire unbroken chain of attempted solutions, stretching from ancient Egypt through Greece, Rome, and into the royal courts of early modern Europe, is how consistently and thoroughly it demonstrates that male pattern baldness wasn't wasn't a modern anxiety invented by shampoo commercials and hair loss supplement advertisements targeting insecure men scrolling through their phones. It was a recognized, documented, deeply persistent human problem for at least 4,000 years of continuous recorded history, generating an unbroken historical record of failed remedies that spans civilizations with no contact whatsoever between them, all independently arriving at the exact same basic conclusion. Baldness is annoying, and humans will try absolutely anything, including donkey hooves, pigeon droppings, and live birds strapped to their heads, to fix it. So when did ancient humans actually start going bald? The genetic machinery behind it appears to be genuinely ancient, with many of the underlying variants predating modern humans entirely, and tracing back through deep evolutionary history shared loosely across the broader primate family tree, even if the specific human pattern emerged through its own independent evolutionary path, separate from anything happening in chimps, gorillas, or macaques. The particular genetic markers responsible for the common, widespread form of male pattern baldness seen today most plausibly trace back to a population shift occurring sometime after early humans migrated out of Africa into Europe and the Middle East roughly 40,000 years ago, embedding a hormonal sensitivity to DHT that has been quietly riding along in the human genome ever since, waiting patiently for its carriers to live long enough to finally express it. Whether early Paleolithic humans actually displayed visible baldness at any meaningful scale remains genuinely unknowable from the available evidence, almost certainly suppressed by brutally short life expectancies that rarely allowed anyone to live long enough to show it clearly. But by the time ancient Egyptian civilization rose along the Nile, the trait was clearly common enough, clearly recognized enough, and clearly worth painting onto more than 100 tomb walls across 2 millennia of continuous artistic output, treated with public neutrality and genuine cultural acceptance, even as an entire parallel industry of bizarre, ultimately useless remedies quietly flourished in the background, driven by the exact same private anxiety that still sells billions of dollars in hair loss products today. The next time you notice your own hairline doing something you'd rather it didn't, take some small comfort in the genuinely ancient company you're keeping. You're participating in a tradition that apparently followed our ancestors out of Africa, embedded itself in the genome of an entire continent's populations, got painted without judgment onto Egyptian tomb walls by artists who treated it as completely unremarkable, drove Julius Caesar himself to invent the comb-over out of sheer desperation, and convinced otherwise perfectly intelligent, accomplished people across multiple separate civilizations to rub donkey hooves, pigeon droppings, and lion fat directly onto their own scalps in increasingly desperate hope that something, anything, might finally work after thousands of years of continuous failure. Spoiler alert, 4,000 years later. Mostly, it still doesn't.